Welcome Math 252. We're working on problem 31 from section 5.2 of the Hughes-Hallett text. In this problem we're given a picture which I've reproduced below for you here. It's a graph of a function f of x, and we're asked to find four different integrals. We don't know any of the numbers other than we've been given the green area and the red area. Now the thing you need to remember, and the thing we're going to need in order to find these integrals, you need to know that when you have the lower limit on the integral is less than the upper limit, which is the usual case, that's how you typically set up an integral, then the result when you do the integral is going to be positive if the function is always positive. It's going to be giving you back area. However, it's going to come out negative if the function is always negative between those two limits. So you'll get the area, but you'll get the area with a minus sign in front of it. And that's the situation they set up here. So let's go back to looking at our picture. There's our function. There's our green area, which we happen to know is 13, and our red area, which we happen to know is 2. And I put in a little dashed line there up between b and c, and I'll explain that in a minute. So now let's take a look at these four integrals we're supposed to be calculating. The first one asks us to find the integral from a to b of f of x. So our lower limit is less than our upper limit. A is less than b. We're integrating a function that is above the x-axis, that is positive. So when we do this integral, we're going to get the area back. And we've been told the area is 13. So this integral must be 13. Now this next one, we're integrating from b to c. Now in this case, the lower limit is again less than the upper limit. B is less than c. But what we're integrating is below the x-axis. So when we make the Riemann sums that are used to calculate this integral, we're going to get negative numbers because we're going to get negative function values for f. So in this case, when we go to the limit, when we look at the integral from b to c of f of x, we're going to get the negative of the red areas, so we're going to get minus 2. Now for part c, we've been asked to integrate from a to c. Now this is another feature of the integral that you're going to get used to. When you integrate from a to c, it's the sum of what you get when you go from a to b and then go from b to c. So we just calculated those two numbers. So the integral from a to c is going to be the integral from a to b, which we just calculated as 13, plus the integral from b to c, which we just calculated as minus 2. And when you add 13 and minus 2, you get 11. Now finally, kind of a sneaky question, we've been asked to integrate from a to c, but now we're integrating the absolute value of f of x. Now we're no longer integrating the same function. Between a and b, the absolute value of f of x looks identical to f of x because f of x is positive between a and b. But from b to c, the absolute value of f of x isn't down below the x-axis. It's been flipped over, and it follows the curve that you see with that little dashed line. Between b and c, the absolute value of f of x is a positive number. So we can get the integral from a to c by first looking at the integral from a to b, which is going to be 13, and then adding the result we get when we integrate from b to c. In this case, when we're integrating the absolute value of f of x, the function is positive between b and c. So instead of getting minus 2, we're going to get plus 2. So the integral from a to c is the sum of these two numbers. It's 13 plus 2, or 15.